Alrighty, so we are moving on. We are finishing up this unit today, which is exciting, okay? It is almost over. It will be over after this beautiful Friday. Okay, so just like everything we do, we always, or typically, we end with the graphing, okay? And when we start a graphing section, we always start by giving you that vertex form, right? Okay, so looking at this one, I look at this equation, and what are the letters that I see? What do I notice? Okay, Y. What other letters do you see? H and K. Do you remember them? I do, okay, because I've seen them every single graphing section that we've done so far, right? And so have you. So we have to recall what those are. There's one more letter up there that we've also seen every single time. What is that? Besides Y and X. A, yeah. A, H, and K. Fun. What kind of friends are these people? These variables. Let's start with H. What's H? He's what? He's bad, yeah, okay. H has always been my bad friend because he's deceiving, right? Okay. And is H horizontal or vertical? Always horizontal. Okay, then we talk about K, and K's my good friend. Yay. And he's what? Vertical. Okay, and then A is just that friend in the front. He's got a lot going on, so we'll talk about him when we fill this out, okay? This is literally the same as what was on almost all the note sheets, okay? So we'll start filling it out. We just said H is horizontal. That means if I see a plus H, that means we're going left. And if I see a minus H, that means we're going right. Opposite of what I would think, right? That's why we call him our bad friend. And then K is my vertical. So a plus K is going to mean go up, and a minus K is going to mean down. Beautiful. Okay. I'm going to give you a second. I want to see if you can fill out the rest of these blanks. See if you remember what they are for A. If A is negative, the function is what across the what? Yep, reflected across the X. Good deal. Or flipped. Yep, if you wrote flipped, it's the same thing. I don't care. Okay, and then we look at the just digit of A, right? Because the sign tells me, is it reflected? Or if it's positive, obviously it's not. But if I just look at the digit of A, that's why those absolute value bars are around it. If the digit is bigger than 1, that represents a vertical stretch. Good. That was a big yawn. Yeah. And then if A is less than 1, okay, what does that mean? Compress or shrink. Probably should know both words. Okay. Fun. So those blanks, okay, all of that information is always the same for everything we graph in Algebra 2. Okay, so really no reinventing the wheel here. Okay, what's new for these? For these exponential graphs, okay, it's this right here. Okay, so the asymptote. What is an asymptote? We talked about these in the rationals unit. What's an asymptote? No one? How do we draw them? Like a dashed line, right? There are those invisible walls, okay? So when we are talking about exponentials, all of these have a horizontal asymptote. And it's always going to be at the equation y equals k. Y equals k. Okay, so once again, those asymptotes are just invisible walls that the graph's going to get really darn close to, but it's never going to touch them. It's never going to cross them. Okay, if I were you, I would box this in, write the word exponential right here, And when I am doing my studying later for this unit, okay, this is something that just needs to be in my brain, okay? And it will be after we do a couple of these, but just make sure we know where this is, okay? So once again, all of these exponentials have a horizontal asymptote at y equals k. We know where k is, right? Because it's the number being added or subtracted, okay? They also, all of them, have a domain of negative infinity, positive infinity. That's awesome, right? Okay, if we think back to last semester, a lot of the things we graphed had that, okay? So that makes it easy on me. All of them are going to be that for domain. And then the range, let's think about this, okay? If I have a horizontal wall on this graph that I can't cross, right? Can my range go down forever and up forever? No, because it can't cross that wall, okay? So when I say that it's either negative infinity to k or k to positive infinity, it's because it's on one side of the wall or the other, right? Okay, and that's going to make more sense when we do one. So let's go ahead, go to this next page, and go to Desmos. Ready, set, go. I want you typing this in. F of x equals 3 to the x power. Go type that in. Make sure you know how to type an exponent into Desmos. So we just said horizontal asymptote. Again, we found it by looking at Desmos, or we could look at the equation and see, hey, there's no k value here, right? So that just means it's 0, okay? So y equals 0. There's no vertical asymptote. None of these exponentials will have a vertical asymptote, so that's an easy one. And then again, just give me some points off Desmos. Enough to where I can get the right shape. What'd you get?
Nothing.
Oh, nothing? It won't go?
0, 1.
All right, we got 0, 1. What else did you say? 1, 2.
3.
1, 3, you mean?
Yeah.
Oh, sorry. Can't hear. Okay, what else? 2, 9. Okay, that one goes off a little bit, but that's okay. All right. So it doesn't have to be the most beautiful thing in the world. Just make sure that your sketch is accurate, okay? And really, the thing I'm going to count off on that I'll see, or that I sometimes see, that I hopefully won't see with you guys, is that people try to cross that asymptote, right? Okay, and that shows me that you don't understand what an asymptote is. So make sure your arrow does not cross down over that asymptote line, okay? Cool. All right, now we're to the fun stuff. Okay, starting with domain. It's always left to right. What is this doing? Yeah, negative infinity, positive infinity. They're all going to do that, okay? And a little explanation behind that is there's no restricted x values for an exponential. Why? Can I have negative powers? Yeah, and I can have powers of 0, and I can have positive powers, okay? So there are no powers that don't work, which is why the domain is not restricted in any way, okay? But then we talk about range, bottom to top, okay? Is this going down forever? It's not. It wants to, but it can't, okay? It's stuck where? 0, that asymptote line, okay? Make sure you put a parenthesis on that, okay? Because if I put a bracket, that would mean that it could equal 0, but it doesn't, okay? It can't. So we're starting at 0, and then are we going up forever? Yes. So 0, infinity. Are we okay with this? Okay, bottom to top, 0 to infinity. Okay, then we go to our end behaviors. And just like always before, for the x's, we copy the far ends of the domain, okay? So in this case, negative infinity, positive infinity, right? Comes from the domain, left, right. You could even label these left, right if you want to, okay? And now I'm asking myself, at the far left end, at the far right end, what's y doing? So we'll start with the left end, okay? If I look at this arrow, what's that doing? The left arrow, is it going up, down, or is it getting stuck? Stuck, where? At 0. Yeah, it cannot go. It's a downwards arrow, but it can't cross that asymptote line. Okay, it's stuck. Then I go to the right side. I go to the right arrow. Okay, as x goes right. What's this arrow doing? It's going up forever. What do we call that? Infinity. Okay, you'll notice those are actually the range values. Okay. Will they always be in that order? No, because sometimes these get reflected, so just pay attention to that, okay? But that's how we do this. Next up, we talk about intervals, okay? When we think of an interval, we think of what do we think of? Roller coaster, thank you. If this was a roller coaster, moving from left to right, what would it be doing? It'd be increasing the whole time, right? So we copy the whole domain. It's always the domain. It is never the range for an interval. People are still missing that on the test, so please stop. Always the domain. Okay. And then lastly, x and y intercepts. You have decimals right in front of you, so this should be the easiest part. What's the x-intercept? None. Yep. Doesn't cross it. Okay, it can't. And what about the y-intercept? 0, 1. Beautiful. What questions do we have? We feel okay with this? Hopefully the more graphing we do, the easier it gets, okay? So we are moving to this next one, number 2. Number 2. I'm going to give you a couple minutes. I want you to try this one. Okay. Starting with the asymptote. What do we got? The asymptote. That's where we start these. Always. 5. Okay. Is it y equals 5 or x equals 5? Yeah, y. Duh. Okay. All of these are y equals 5. And again, I found this on Desmos, or I could just look and find my k value in this equation. Okay. Either way. And then on Desmos, I need some points on this thing. What you got?
0,
0, 6. Anything else? 2, 9. That goes off a little bit. That's okay. All right. That's probably good. Beautiful. Does yours look like mine? Yes? Does anyone have a question? Okay. Domain is what? Left to right. Yep. Left forever, right forever. What about the range? It sure would. 5 to what? Positive infinity. Good. This is starting at 5 at that asymptote line. It's going up forever, okay? It cannot equal 5 though, so make sure you put a parenthesis on the 5. All right, in behaviors, what should I copy right here for my x's? Domain. Always, right, Brayden? Always. Okay. And then we ask ourselves, okay, as x is going to negative infinity and positive infinity, what's y doing? So we'll start with negative infinity, okay? As x goes left, what's y doing? What's the left arrow doing? Stuck at 5. Good. And then as x goes right, the y arrow is doing what? Up. Good deal. Okay, so left arrow is getting stuck at 5. Right arrow is going up forever. Are we all good with that? Okay, there's no excuse for missing these anymore. Okay, you used to be like, oh, this is so hard. These are so difficult. Okay, and there really wasn't an excuse back then either, but there was a lot of information at once. But these should be starting to click now. Okay, interval. What do we think? Increasing. What'd you put there? Always the domain, right? Never the range. Make sure that if you, like for instance here, we don't have a decreasing interval, so you'll notice I put a little slash. You could also put NA. Don't leave it blank though, because that makes me think you don't know it. Okay, so please at least just put a slash if something doesn't exist, okay? X-intercept, what do we think? Nothing. And y-intercept? 0, 6. How are we feeling? Good? Okay, next page. Okay, these two, I want you to star. Ooh, that was an ugly star. I'll do another one. Okay, star 3 and 4. I'll tell you what the stars mean at the end today. Star number 5. And then we're going to do 6 right now. Okay, so go type this one in right now. Give you a couple minutes here. Try this one out. Work together. Alrighty, so once again, okay, little troubleshooting. If we can't get this power to stay up top when we type it into Desmos, we put it in parentheses, and make sure you put the parentheses around the whole thing like this, okay? Don't put them in any other way, okay? Good. So now let's start with the asymptote, right? That's how we always start graphing these. Okay, what is it? It is 2. Horizontal or vertical? Horizontal. Okay. Give me some points. What do we got? 0, 10. 1, 6. 2, 4. Okay. Beautiful. Okay, let's go. Domain, what do we think? Yeah, negative infinity, positive infinity. Question for you. Is positive infinity, negative infinity the same thing? No, and it will be counted wrong every single time. I'm still seeing people do that, okay? You cannot go left to positive infinity, nor can you go right to negative infinity. Okay, so I would count that wrong if you flipped them. Don't ever flip them. Okay, I should never see a positive infinity on the left and a negative on the right. It should always be negative then positive. Okay, what about the range here? Bottom to top. So at the bottom, I don't think this is going down forever. Yeah, this one's the same as before. It's still 2 positive infinity, okay? Bottom to top, y values. This has nothing to do with left and right anymore. It's just bottom to top. So at the bottom, it's starting at 2. It's getting stuck. And then to the top, it's going up forever. Are we okay with that? Okay. End behaviors. How do I start those? Yep, for the x's, right? Okay, and then we ask ourselves, okay, at the left end, as x goes left, what's y doing? What's this guy doing? Going up. What do we call that? Infinity. Okay, and then as x goes right forever, the right arrow, what's the y value of that arrow doing? Stuck at 2. Okay. Roller coaster time. If this was a roller coaster moving from left to right, what type of interval would it be? Decreasing the whole time? Yep. Okay, so copy the whole domain. X-intercept. Nothing. Yep, and the y-intercept. 0, 10. Okay. Okay, any questions here on this? Okay, so moving right along now, okay? These were the exponential graphs, correct? Yes. What is the inverse of an exponential? Log. Oh, so what do you think we're graphing next? That would be fun. We'll skip number 7. I won't make you star that one. But we're moving on to logs, okay? And actually, the first page of this notes, I don't even really want to do because we're using Desmos. We're saving time, okay? We are going to hop down to the second page at the bottom here. Since we just filled out all the AH and K stuff, okay, we're not doing it again, okay? It all means the same thing. I'm not going to make you fill that out twice in one day, okay? So looking at this log equation, this is actually not the vertex form, but just an example of a log equation, which is totally fine, okay? We still know that what letter is found in the front? A, yep. And what letter is on the inside? H, and he's my bad friend, okay? And then what letter is typically found on the back? Usually K. Sometimes it could be in the front if there's like an addition or subtraction sign instead of a multiplication in the front. would make it a K instead of an A, but again, we don't see that very often. Okay, next thing I want you to do is just like before, box this in. I'd probably write log on it just so we're clear. This is what we have to know, like the back of our hand, okay? So, once again, logs are the inverse of exponentials, correct? Okay, so again, these are inverses of each other. So doesn't it make sense that if an exponential had a horizontal invisible wall, right, a horizontal asymptote, why a log would have a vertical asymptote, and instead of K, it's going to go through H, right? Those are kind of inverse concepts, okay? Same thing with domain and range here, right? They look flipped because whenever I take the inverse of an exponential and I'm graphing a log, and this will make more sense when we do one, okay? The range is not restricted with a log, okay? So they can go down forever, they can go up forever, okay? But the domain is restricted because what do I know about logs? I can't have negative A values, right? We had extraneous or no solutions when we had those, okay? So please, please, please make sure we understand that concept of domain, why that one's restricted for logs but not exponentials, and why the range is not restricted for logs, but again, it was for exponentials. Let's go do one, and this will click for us, hopefully. Okay, we're going to go type this into Desmos. How we're going to do that, okay? We'll go into the Functions tab, and we're actually going to scroll down to the little heading that says Calculus. There's 3 buttons there, okay? And here's what they look like. One of them says LN. What do you think that button's for? Natural logs, and we're going to graph some natural logs. So pay attention to, if you see LN, that you use that button. Then we have 2 other buttons. One says just plain old log, and then the other one has log with a little base on it, but I think it uses the letter A, which drives me nuts, okay? But those are my 2 options. Which one do you think I should pick for this? The one with the A, because it's got a base. Why would I ever pick this one if I didn't have a written base? Because that would mean it was an invisible 10. Okay, good. You guys are smart. All right, go type this in. Go type this in. Okay. So again, we saw on Desmos that we had a vertical asymptote going through 1. Could I also have found that just by looking at this equation? Yeah, because I'm looking for not K, but H, right? And wouldn't that be a positive 1? Yeah, okay, because again, it's my bad friend. It looks like a negative 1, but it's not. Okay, now give me some points on this thing. Um, 0, 2. Are you sure? I think it's 2, 0. Yep. Okay. Then what? What? Give me something else. 5, 1. Okay, beautiful. That's what this looks like. And again, if I took this and I rotated it, if this will let me, bam. Doesn't that look like what we just graphed? Yeah, okay, this is the inverse. This is the inverse, okay? Cool, hopefully. Okay, domain, what do we think? 1 infinity, good. 1 to infinity. This does not go left forever. It starts at that asymptote line and goes right forever. What about the range, though? Negative infinity, positive infinity. It is going down forever. It is going up forever. All of these will, okay? All of these logs will do that for the range. Okay, the asymptote. We just graphed it. What was that equation? What equals 1? X equals 1. Good. Braden, are you okay? So the horizontal ones are Y equals, and then the vertical ones are X equals.
I thought we just did.
Yep, you're okay. All right. End behaviors, we'll set them up the same way. So for the x's, we always put the far ends of the domain. But this time, what's my domain? Yeah, 1 infinity. Okay? Now we're asking ourselves, okay, what is y doing at those ends? Okay, at 1 and then at infinity. So if I look, when x goes to 1, that left arrow, what's y doing? Negative infinity. Okay, and then what about as x goes to positive infinity? As x goes to the right arrow? It's going up forever. Good. Okay. What type of roller coaster is this? Increasing. What would we put there? 1 infinity. Yep, always the domain. X-intercept, what do we think? 2, 0. And the y-intercept? None. Okay. Don't flip your intercepts. A lot of people did that on the last test. Okay, there's no credit, no partial credit if you flip those. You should know the difference now between x and y intercepts. That should be the easiest part of this. Okay? Any questions on this? Okay. I want you to put a star on the next one. And then I want you to flip the page. I want you to put a star on this first one. And we're going to the second one. This guy. All right, I'm going to give you a couple minutes. Try this out. Okay, what do we graph first? Asymptote, what is it? 3, and it's vertical, right? So we found that on Desmos. We also could find it right there, my H value. Okay, what are some points on here? Guys, let's lock in. Come on, let's end the side chatter. What are some points on here? 4, 0. Give me another one. Say 5, 4. Okay. Beautiful. How do we feel about this? Okay. What's the domain? 3 infinity. What's the range? Okay. We just said that the asymptote was x equals 3 on vertical. The end behaviors. Okay, so as x goes to 3 and infinity, let's ask ourselves, what's y doing? So as x goes to 3, what's y doing? Negative infinity. It's going down forever. And as x goes to positive infinity, as x goes right forever, positive infinity, what's y doing? Going up. What do we call that? Infinity. Okay, so just remember, x is always left and right, y is always bottom and top. Okay, so make sure we know what we're looking for when it asks us what's y doing. Don't think about left or right. Think about up or down. Okay? Increasing or decreasing? Increasing. So copy domain. X-intercept? 4, 0. Is 0, 4 the same thing? Don't do that. And then the y-intercept. Okay. How do we feel about this? Everybody, thumbs up, thumbs to the side, thumbs down. Okay. Okay. All right. Right along. Skipping this top one, it's just the parent function, and I don't want to do that, okay? But I do want to do this one. Oops. So we're going to start with this one. Give you a couple minutes here. Try it out. Alrighty. So again, natural log is the button we should have used on Desmos. And make sure that the parentheses are either only around the x, because that's all that the natural log is being taken of, or you just delete them out and don't put them at all. okay? Because it'll let you do that as well. Just don't put them around the +2. Okay, let's graph this. What do we think for the asymptote? 0, good. Domain is what? Oh, sorry, let's graph it first. Give me some points. Give me some points. 1, 2. That's the only one you could find. Can I have a decimal then if you can't find another one? Anybody? What? 1.90. Okay, was there anything else? Nothing? What? They could be decimal points. Like, I know that there's a million infinite amount of points on this thing. Give me another point.
9 and -4.5.
Perfect. 9, -4.5. Beautiful. What's the domain here? 0, infinity. What's the range? In behaviors. Okay, and then for the y's, infinity and negative infinity. Good. The left arrow is going up, the right arrow is going down. Okay. Interval, what do we think there? Decreasing. Good. Copying the domain there. X-intercept. Okay. And the y-intercept. Nothing? Okay. How'd we do? Excellent. Okay. The very last page. Get there, get there. Star that one. There should be 6 stars in your notes. Those are your homework problems. All 6 of them. Okay? Okay, I'm done. Okay. 6 problems total. The ones we starred.